Today I'd like to talk to you about compound radius milling. You would have seen my other video on radius milling where I show you a simple way to hold it in the vise and just rotate it around the hole that you have, and you can make a pretty good radius that you then just touch up the file to finish off. Now this time I want to talk to you about a compound radius that sort of leads on from the previous video. Now some people have said, oh, what happens if you don't have a hole? Well, I'll just use this barrel strip as a model to show you what I mean. Before, you would just put your pin in and rotate it. The cutter would just cut and then you'll file it. But compound radius is one that has more than one radius on it. As you can see, this hole is not the same distance from either edge. Just say you wanted to beautify that corner, or it may need clearance to clear from something. Let's just say that's 20 and let's just say that's 15. You could put on a 20mm radius, but it would finish there. You could try to put on a 15mm radius, but it would cut that out right there, so you'd have a step. So you either have an incomplete 20 or a ridiculous 15. Or what you can do is do a compound radius. Start off at 15mm, go across at 20. But how can you do that? And we're just talking a manual mill. You can use the scales, but if you've got the money, buy a dryer, digital readout. Best investment you'll ever make. But that's only just to make it accurate. So what you do, and this is where it comes back to, even if it hasn't got a hole, so we say it hasn't got a hole at the moment, you set it up in your vise. You set the position of where you want your origin to be. You then zero your drive. Now, it's held in this position, the horizontal position. The other one was rotated that way. So then with your cutter, just say you choose a 10mm cutter. I'm doing that for easy mathematics. So that's 15, that's 20. So for it to touch there, that height is 20mm. For it to touch there, it is 25mm. So basically you have to calculate a radius, which is the center point of the drill, from 20 to 25mm. In this, at 45 degrees, that radius is going to be half of that. 20, 25. So in the center, at 45 degrees, that radius is going to be 22.5. So basically, what you do is you get your calculator and you use the polar coordinates. So you know that, okay, from here to here, 90 degrees. How many steps do you want to make? Let's say every 10 degrees. So 9 steps. So then all you have to do is subtract one radius from the other, 20 from 25, leaves you 5. You've got 10 steps, so each angle moves in half a mil. So you then can either if you use programs like SolidWorks or a CAM program, and it allows you to record your screen moves, you can just use the dimensions, measure them up, and as you're recording and changing it, as this video will show you, it will then just show you the steps. Then you just get your mobile phone or your laptop and you just play it back, and each step will tell you. But you can just use your calculator, polar coordinates, you know the angle, 90 degrees 15, it then will tell you how far it is from the origin, X and Y. Then you move your next one, get your polar coordinates for the next 99 degrees, because we've got 10 steps, and you know it's half a mil less, and then that will give you your X and Y, and you just wind your table. When you cut, always wind your table so as it moves away from the cutter and then move into the cutter. Don't go, because you'll end up cutting it. So you can do your 10 radiuses that way. Then if you think, okay, that's a bit rough, you can then calculate. You can do a spreadsheet on Excel, use that, or just get your calculator out and do it in real time. So that's how you do compound angle. Now, that also allows you to do cam milling. Now, what is a cam? A cam basically can be just a disc, a circle, where the center rotation is offset. So if you offset that 5 mil, that then spins around, and that is then a cam. Now, cam design is fairly simple for simple cams, of course. You have your basic shape. You know that you want the follower to move a certain distance. So that might be with the valves, you want the valves to go in, say, 5 mil. So from your large diameter, you know you have your smallest diameter 5 mil smaller. Let's see. Oh, here we go. 5 mil smaller. So then, with the shape of your cam, you then want it to be open a certain length of time. Now, time in the cam is really degrees. So you want it to be open, say, 30 degrees. So vertical will then go down 30 degrees, down to the smaller, and off you go. Exactly the same as this previous compound radius I showed you. Divide your cam up into 360 degrees. Then all you have to do is say, right, that's that distance and that angle. Again, polar coordinates. You can put your cam in, get your milling cutter, mill it. If you clamp it in there that way, you can mill like that. You then have a cam. You have to dress this cam up. We're only roughing the cam out, and depending on how many degrees you want to divide it up is how big the cusps are and how much you have to file. But if you wanted to make, say you had a model engine and you wanted to make up a cam grinding machine, which is just a grinding wheel attached to a lever and a follower that just follows a wooden or sheet metal profile, can be 10 times bigger, and the ratio between what that moves and the grinding wheel moves is 10 to 1. So that moves 10 thou, that will move a thou there. So that's how simple a cam grinding attachment is. So you may want to build one of them, so out of wood or something, so just use that principle. Or you may want to mill a multi-load cam like this. You think, I haven't got a dividing head, I haven't got anything sort of elaborate to do it. Again, instead of using the diameter, you get yourself a ball end mill. So instead of cutting that way, you're cutting on the ball. You get a 10 mil ball, 5 mil center position. Exactly the same. The only difference is the clearance you have between one lobe and the other. So what you would do, set your cam up, that's the highest point, take it over. But this time you wind across, down, 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 down. So you then can do 180 degrees. So if you milled your block up with a square and that grips in the vise, you can mill your cam, the important areas, then just undo the vise, turn your cam upside down and finish milling. So as you can see, that clearance, this cutter might be too large, but you could rough it out and do it, then file it up. So you can easily do compound radius milling, make your own cams. Camshaft design is not that hard. You could use, if you had a indexing rotary table type of thing, you could mill like that, like that, like that, that's fine. But if you had a cam that actually dished in and you couldn't mill flat it across, you can do it with this principle. So give it a go. If you've got a little engine you want to do, try it that way. If you haven't got a hole in your link that you want a radius and you want it, or it's offset different distances, just use the compound radius milling and touch it up with a little file, and you've managed to save yourself a fortune on rotary tables, do a fairly accurate job, and be satisfied of the quality of the work you've done and the skills you've learnt. So, thanks for watching.